Automobiles have become an integral part of modern civilization, and with our reliance on transportation comes a demand for adequate parking. Nearly all building structures will incorporate some parking features to accommodate their workers, customers, and deliveries. Office buildings and retail stores across America are constantly trying to attract new customers, and it's the parking lot that provides that critical first impression. Today's parking lot pavements are engineered with the latest advances in road science, which are designed to balance the demands of traffic along with the needs of the motorist. The asphalt industry is constantly utilizing new technology to improve the quality of our product. Our goal is to provide a finished pavement that is smooth, sustainable, safe, and durable. My name is Brian Wood. I'm Executive Director of the Plant Mix Asphalt Industry of Kentucky. This video provides examples of best practices and guidance for owners and engineers who want a parking lot pavement that is designed and constructed to provide decades of great service.
Early in the design process, engineers must calculate the appropriate thickness of the pavement structure. Most asphalt pavements are characterized as a layered system where different materials are utilized and each layer contributes to the overall strength and function of the pavement structure. Structural pavement design is a complicated process using mathematical formulas typically performed using specialized computer software programs. There are free and readily available programs such as Pave Express that were developed to help designers choose the appropriate thickness of materials to handle the expected loading conditions. The two most important and sensitive parameters in the determination of the pavement thickness are the quality of the subgrade materials underneath the pavement surface that are providing foundational support, along with the types of vehicles and their axle weights that will ultimately load the pavement. Most parking lots are built on a foundation of native subgrade soils. A fine-graded clay soil must be well compacted at the proper moisture content to achieve a good working platform. The weight and frequency of truck and passenger vehicle traffic over a pavement is a critical and sensitive parameter in designing the thickness of any pavement structure. Understandably, pavements that experience heavy truck traffic will require a thicker section than one that hosts only passenger cars. Most commercial building structures have well-defined areas for passenger car parking. These sections of pavement would be classified as light-duty traffic and would contain the least overall thickness. For heavily traveled areas with substantial truck traffic, such as access roads around dumpsters and areas leading to loading docks, the designer will need to consider a heavy-duty design, which results in much thicker sections. To achieve optimum performance and durability of a parking lot, an asphalt mixture should be designed for the specific project conditions. Most state and local agencies have detailed specifications for asphalt mixtures, and many designers will reference them in the contract documents. An asphalt pavement is made up of two primary components: mineral aggregates and liquid asphalt binder. The asphalt binder acts as the glue and serves to waterproof the mixture. And once blended, the coated mineral aggregate acts as a stone framework that imparts strength to the system. Asphalt mixtures also include a small percentage of air voids, which are necessary for pavement durability. The performance of the mixture is affected both by the properties of these individual components and their combined reaction in the system. Parking lots are somewhat different than roadways because vehicles are not traveling at high speeds and are far more likely to experience turning movements. Parking lots may experience oxidation, aging, tire scrubbing, and some brittleness not often seen on heavily traveled roadways. For that reason, it may be best to design a mixture specific for the application and not rely entirely on the DOT specifications. Generally speaking, asphalt mixtures utilized in parking lots should be higher in total liquid asphalt content than a similarly traveled roadway. In most cases, the grade of liquid asphalt is specified according to the climate and level of traffic for the application. A wide variety of mineral aggregates are used to produce asphalt pavements. Processed aggregate, such as limestone or dolomite, is obtained from a surface mine or underground quarry. Gravels and sands may be obtained from pits or through dredging operations. These materials are crushed, separated into distinct size fractions, washed, or otherwise processed to achieve certain performance characteristics. Some asphalt mixtures will utilize synthetic aggregates, or materials that are not mined or quarried, and are often the result of an industrial byproduct, such as blast furnace slag. The liquid asphalt binder and aggregates are heated and combined in an asphalt mixing plant. The plant is carefully designed to blend the materials in exact percentages in accordance with the mix design. The asphalt is then loaded into trucks and delivered to the job site for spreading, finishing, and compaction. Warm mix asphalt is an emerging technology whereby production and construction temperatures of asphalt mixtures are significantly reduced by 50 to 100 degrees Fahrenheit. This is achieved by foaming the asphalt binder or by using a chemical additive. In either case, fumes and emissions are greatly reduced, and the asphalt remains workable at lower temperatures. Warm mix is rapidly gaining acceptance, and many states already allow it to be used in all paving applications. The recycling of reclaimed asphalt pavement, or RAP, is an excellent way to reuse an asphalt pavement that has reached the end of its traditional service life. Recycling RAP in new asphalt mixes reduces the demand for virgin materials and, in the case of parking lots, can stiffen the mixture, which can minimize scuffing or tire scrubbing. Most state agencies currently have specifications allowing the use of RAP and providing guidance on the design and testing of those mixtures. Some contractors will even utilize reclaimed asphalt shingles, or RAS, as it provides another opportunity to reduce the virgin asphalt binder while recycling a material and freeing up valuable landfill space. The use of recycled asphalt pavement and shingles is a common practice in the asphalt paving industry worldwide. These products have the same properties as virgin materials and produce a quality pavement. The consistency, quality, and moisture conditions of the naturally occurring materials are all factors in the pavement design process and must be verified in the field. Engineers and inspectors must determine if the existing site materials are suitable for the project. If deemed unsuitable, they should be removed and replaced with better materials, mechanically improved, or chemically stabilized. It is often said that the three most important things to consider when designing a pavement are drainage, drainage, and drainage. It is critical that any pavement be well designed for proper drainage. Drainage issues are frequently a major cause of parking area pavement failures and should be given special consideration during the design and construction phases. Without proper drainage, stormwater can cause premature deterioration of the surface layers. In addition, moisture will penetrate the subgrade layers, which could weaken the entire pavement structure, resulting in severe distress. When designing a pavement structure, both surface and subsurface drainage are considered. Similar to the approach when building a new house, pavements require both a roof and under-drain system. The pavement surface should be sloped to drain stormwater. Even with the best construction practices, it is inevitable that water will penetrate the pavement structure. Therefore, pavement should be designed to drain that water to protect the subgrade materials from degradation. Parking areas should have a minimum slope of 2% to facilitate drainage. Pavement cross slopes of less than 2% are difficult to construct without forming flat spots or depressions that can lead to ponding water or bird baths. There is a tendency to overlook the need for grade information at key points in intersections, crossovers, and transitions between grade lines. Once the subgrade has been properly prepared, most pavement designs will require an aggregate layer be placed over the existing site soils. This layer provides some load-carrying structure and improves the working platform for the construction equipment necessary to place asphalt paving materials. Following the placement and compaction of the soil and aggregate layers, 2 or more layers of asphalt pavement are added to complete the pavement structure. The most common approach is to place 1 or more base asphalt layers over the aggregate layer and then a surface mixture as the final riding course. It is important that the owner or prime contractor select a local asphalt paving contractor familiar with the materials that perform best in that region and who is experienced in constructing quality asphalt pavements. The paving contractor is responsible for quality control on the project and will be responsible for the quality of the asphalt mixture and the finished pavement surface. The paving contractor should utilize a self-propelled asphalt paving machine capable of producing a smooth and consistent layer of material. Through proper techniques at the asphalt plant and during trucking operations, precautions should be made to minimize material segregation. The contractor must also ensure adequate compaction equipment is available to meet the project specifications while achieving a smooth finish. The asphalt base course should be placed directly on the prepared aggregate. Asphalt mixtures used in base applications are characterized by larger aggregates and are typically placed in thicker layers. The base layer should be placed and compacted to the thickness indicated on the plans. The thicknesses represents the finished and compacted pavement thickness, not the loose thickness prior to compaction. Compaction of the asphalt base layers is critical to the performance of the pavement because it provides the structural foundation to support the weight of the traffic. To achieve compaction of a base mixture, research and experience indicates that the thickness of the layer must be at least 3 times the size of the largest aggregate in the mixture. The purpose of a tack coat, seen here, is to promote the bond between the pavement layers. The tack coat material is typically placed just prior to paving and must be applied to a surface that is clean and free of debris or loose materials. After the water evaporates, the product will dry and become sticky, indicating it is ready for the next layer of asphalt. The asphalt surface layer is typically placed in one layer and compacted to the finished grade showed on the plans. Rolling should begin as soon as the asphalt material can be compacted without being displaced and continue until density is achieved and all the roller marks have disappeared.
As you can see, there are a number of factors to consider when designing a new asphalt parking lot. Proper thickness, along with good practices for construction, will lead to decades of excellent performance.